another episode of MrLopezClasses.com. We are going to continue with our transmission class. And in this episode, this is the episode number 2 of the chapter 2. We are going to continue with the general evaluation, the general considerations in relation with the different type of transmissions: a straight transmission, a V-drive transmission, a steam drive transmission, I.P.S. that we are going to analyze. This is a Volvo design, and the jet drive. We are going to check the advantage and disadvantage in between those transmissions. In this episode, in the second episode, we are going to continue. If you remember, in the previous episode, we finished in this slide in the comparison in between the V-drive versus the steam drive, and what is better, what is more recommended. That depends of the situation, and that's depend of the consideration about the speed of the boat, and about the RPMs and the torque. Okay. V-drive versus steam drive. Why? Oh, because an inboard running gear generates a lot of drag. That's true. That's true. Once again, an inboard running gear produces a lot of drag. Yes, when you have the propeller and the rudder under the boat, like this situation, this situation produces more drag than this one. This one produces more than the other one. Of course, it's under the boat. Yeah. Of course, reducing speed and reducing miles per gallon versus the steam drive. Yeah, the steam drive is more efficient in those aspects. Also, a steam drive angle of thrust is virtually horizontal. Yes, if you check this propeller is considered horizontal, and that propeller is in angle. In that case, which propeller is more efficient in speaking about the thrust? Yes, the horizontal produces better thrust in comparison with the inclined propeller. Yes, for that reason, other excellent design is the surface drive. You remember the surface drive? That system that I explained in our class of intro, in the book of intro. Yes, that system is the more efficient systems, because the propeller is running in the limit of the waterline, and that propeller is not exposed to cavitation. That propeller is exposed to ventilation, and that system is highly efficient. Look at the advantage for that system. Excellent, excellent in comparison with the rest of the system. The only inconvenience with that system is that the propeller is located outside of the boat. The majority of the peoples, they locate that propeller under the swim platform to protect the propeller and to avoid accidents when the people is swimming. Yeah, this is the inconvenience. But for high performance, this is a great design. That design, the surface drive. There are different manufacturers dedicated to produce that system. Yeah, Harness and Drive, Hamilton, they are excellent manufacturers, proprietaries of that design. Okay, we are going to return to our concept about the steam drive versus V-drive. Okay, this is the typical lower unit. This is the typical lower unit of the steam drive design. Yes, of course, here is located the propeller, and here we locate the flex plate. The flex plate that I explained in details in the chapter 1 of in the episode number 1 of the chapter 5. This is the flywheel of the engine, and this is the flex plate. This is the flex plate. Flex plate. Yes, that flex plate enter in the shaft of the lower unit. This is the lower unit of the sterndrive, and the flex plate enter over there. Where is located the flex plate? Yes, the flex plate is located, is bolted on the flywheel of the engine. Of course, there are flex plates for gasoline, like this one, or there are flex plate for diesel, and the flex plate for diesel is bolted on the flywheel of a diesel engine. The secret of the flex plate absorbs the momentum of the engine in the moment that you engage the gears. I explained in the episode number 1 of the chapter 5 with extreme detail those flex plates for both, for diesel and gasoline. I recommend that wonderful video. Okay, this is the situation. We have the lower unit, and this is the flex plate, and this is the flywheel, and this is the situation. This is the situation. In other episode, in chapter 7, I am going to explain the procedure to align the system, the procedure to introduce that lower unit appropriated into the flex plate. With Professor Rodriguez, we are going to analyze what is the technique. Professor Rodriguez have a special tool in order to align. This is a special tool in order to align the shaft, the shaft of the lower unit in the moment that you want to insert the lower unit into the engine, in the transom. Exactly, that tool helps in order to align the system before you introduce the lower unit into the engine. This is another wonderful episode that we prepare for you. Ready? This is the situation of the inboard, outboard. In general terms, the sterndrive or I/O system, inboard, outboard, is more efficient, is widely used basically because you combine two excellent scenarios. The excellent outboard lower unit with the propeller outside and high RPMs on those systems, with the inboard heavy inboard gas or diesel engine. This is a perfect combination. This is a perfect design. For that reason, it's widely used every day more and more and more. Okay, my friends, this is the example about the sterndrive with an inboard diesel engine. And yeah, there are a lot of advantages, and once again, the alignment is the most critical part of that system. Is commonly used. If you check in this particular example, the propeller is a dual propeller that we are going to analyze. We are going to analyze this lower unit with dual propeller with Mr. Rodriguez, and we are going to verify how, when you move the input shaft, the output shaft is moving one into the other one in different direction, each one, because one propeller is right side and the other propeller is left side. For that reason, that system, that wonderful system, produce excellent result. Yeah, this is the dual prop. This is Bravo 3, Mercury Bravo 3, used for diesel application. This is an excellent design. Can you imagine the power of this diesel engine combined with this outboard? This is a great design. There are a lot of combinations, different manufacture of engines with that lower unit. We are going to analyze that situation in the next coming episode. The next coming episode will be nice. I hope you enjoy those episodes. Okay, we are going to check a little more about the sterndrive. In this particular engine, the engine is mounted inside the boat. The transmission or drive unit is located outside, attached to the transom, like in the video. The engine and the drive unit are joined by the torque coupler or flex plate that I explained before, and I am going to explain in details in the episode number 1 of the chapter 5. And the universal joint, of course. That unit outside steer the boat according with the movement of the wheel. Alright, and the V-drive is more efficient. delivering horsepower to the propeller. Only lose around 8% for dissipation of heat and vibration. That's excellent. This is excellent, the design of the sterdrive. That picture is good because you can see the engine located inside. You can see the shaft of the lower unit, and this is the V-drive configuration. Yeah, in this particular case, if you check, the propeller is completely outside, and in this particular case, the propeller is under the boat. This is the limitation. It's a limitation, but I have advantage in other situations. For example, look at this. While the sterdrive offer better performance, that's true, the anti-ventilation plate, this is a plate located here, that plate, this is the anti-ventilation plate, limit the diameter of the propeller. Yeah, because you have that plate, the diameter of the propeller is limited. Yeah, that's an inconvenience. The the diameter of the propeller. You remember in our course of introduction how can affect the performance of the engine, the diameter of the propeller, and you remember the limitations about the how much can I increase the diameter of the propeller. Yes, you have the limitation of the distance in between the propeller and the hull. That distance should be no more than 20% of the diameter of the propeller. That's critical. If not, you introduce a lot of noise, a lot of vibration, and you can destroy the hull. All right. For that reason, this plate, the anti-ventilation plate, limit the diameter of the propeller. In the other example, in a V-drive, you don't have that limitation, and this can be an advantage. Yeah, of course, because in this design here with the propeller over there, you can increase the diameter of the propeller more. You can increase the diameter, and of course the performance in low speed will be better in low speeds. Remember, my friend, the formula to calculate the diameter of the propeller. You remember that formula? Exactly. If you check in the bottom, you have the DAR. You remember what is the meaning of the DAR? Is the Dix area ratio. Oh, how much is the Dix area ratio for a propeller with 3 blades? 0.5. For a propeller with 4 blades, 0.7. For a propeller with 5 blades, 0.9. Ah, yeah. Okay. If the number of blades increase in the bottom, the diameter of the propeller decrease. If I added one more blade, the diameter should be less. Important consideration. Check my book of intro. That's a wonderful book. All right, my friends. Those are the limitations and considerations. This is a nice picture because I have the sterdrive, I have the inline or direct drive, and I have the V-drive here. Yeah, I have the 3 scenarios. The V-drive system offers more space in middle boats than a conventional inboards and require less maintenance and service than the sterdrive. However, sterdrive are faster and more fuel efficient. A V-drive can swim a bigger diameter of propeller. Yeah, this is other of the advantage. For what reason, my friends? What system is more efficient? In general terms, all of them are efficient depending of your boat, depending of the function of the boat, depending of the length of the boat, depending of the capacity of the boat, and depend of the future use of the boat. That boat will be used for a towboat. That boat will be for fishing. That boat will be for the family weekend boat. Depending of those considerations, one system is better than the other one. All right, and the most important part is select the appropriate boat for the use that you want. The majority of the people make a mistake when the people buy the first boat. I did that mistake. Yeah, analyze carefully what is the boat for that moment of your life. In each moment of your life, probably you prefer a different boat. Alright, my friends, we are going to continue with other important, wonderful design. Is the Inboard Performance Systems, IPS. This is, in my opinion, other great design, other great invention. The patent of that design is a Volvo Penta. This is a wonderful system because you remember I mentioned in our class of intro, and I explained in detail in my book of auxiliary system, the bow thrusters and what is the function of the bow thruster and the steam thruster. Yes, it's move the boat lateral. To dock the boat is excellent because it's easy. If you have bow thruster with the joystick, you move the boat lateral. It's easy. That's the bow thruster. With this design, you have propulsion system, forward and reverse, mix it with the bow thrusters, and you can move the boat. You can rotate the boat 360 degrees easily, like a toy. With that wonderful design, that wonderful design, the IPS system that I explained in details in our previous episode in my introduction to marine engineering book. I explained with a lot of detail that system, but we are going to check quickly the advantage of that system. Improve the efficiency at high speed and reduce the fuel consumption. Yeah, because you extend the range of acceleration. The maneuverability is easy. You can rotate the boat 360 degrees because you can rotate each system 360 degrees. That's wonderful. Protect the environment. The comfort internally is like if you are in a luxury car all the time. No vibration. I have a great experience with that system. Once again, this is a combination of a Volvo engine, and the design is Volvo. And there are designs like this with electric motor here. Right now I am going to show that picture about the electric IPS system. Other advantage is the installation is simple, and the space on the engine room is less. Wonderful. You have more space for cargo, and the safety of the boat is excellent. Easy for service and maintenance. The propeller is facing forward, no backward. That's different. And the jet of water is coming out through this tunnel. This is an excellent design. I love it, that design. All right. The propellers are forward facing. At the front of the hydro-dynamic optimized pod unit. Yes. Is working in a disturbed water without any inconvenience, with a minimum of pressure pulses affecting the hull. You feel the boat completely different when you use that system. The performance of the boat is like if you are in a sophisticated luxury car. Exactly the same. This is a great design. The pod unit is designed for an efficient flat hull surface with maximum buoyancy. This is used not necessarily in V configuration. In flat configuration, the performance is excellent. The propeller thrust is parallel with the hull. Remember, this is one important thing in design consideration. The propeller parallel to the hull, the efficiency is better, the top speed is better, and the vibration is reduced. That's very, very critical. And this is the bottom view. This is the bottom view of the system. You have the units over there, and those units rotate 360 degrees. IPS, wonderful design. This is the CF boat. Is one of the most efficient propulsion systems. This is ideal for medium-sized boats in between 30 and 50 feet normally. Can be used with diesel engines around 450 horsepower is excellent. This is for big diesel engines. And this is the electrical that, that I mentioned before. This is the lower unit with an electric motor on top. This is the I.P.S. The I.P.S. hybrid. Some electrical design isolate the transmission from the electrical motor with a clutch. This is an electric clutch that I explained, you remember, in the chapter number 1 of this book. Wonderful. This is another excellent transmission system. It's basically the combination of the typical traditional lower unit with an inboard, but located on top. This is a wonderful design. 360 degrees of rotation. Alright, my friends, and we are going to pass to the jet drive. The jet drive, once again, all of those systems are explained with the extreme details in my course of introduction. In my course of introduction, I spent a lot of time explaining each by each those systems. But basically, the jet drive is a water pump. It's a water pump that suction water from the sea, compress the water with turbines in different stages. When the water is full compressed, pass the water in a funnel. And the water in a funnel produce a jet of water, and the jet of water produce reaction, third law of Newton. And the reaction move the boat in the opposite direction. Finito, that's the definition. Let me explain again. The water is suction from the sea and is compressed with the pumps, normally 2 or 3 stages of turbines with different angle, with different pitch. The water enter in the first turbine, is compressed, and after that enter in the second turbine with more angle, more compressed, and after that enter in the third turbine, more compressed, and after that in the funnel. And in the funnel, what happened when you reduce the diameter of the pipe? You remember Bernoulli in the carburetors in our gasoline class? What happened in that? The pressure is reduced and the speed increase. Yes, because the speed increase in the output of that tunnel. What happened with the boat? Third law of Newton, produce a reaction. And the boat goes in the other direction and the jet of water in this direction. This is the jet drive, my friend. It's too simple. What happened if in the jet of water I have an element like this and I move this element like this or like this? The boat move like this or like this, and the boat move in reverse. Simple. It's simple. With this element, my friends, with this element, that one, the water goes here for right side, for left side, or reverse. This is the output turbine. Yes, this is the jet drive. This is the jet drive. This is the jet drive. The water enter over there. The water is compressed here. The pressure is reduced in the tunnel, and the speed increase and produce the reaction on the boat and the jet of water in this direction. Finito. This is the jet. There are a lot of advantages of that system. This is good for, you remember the jet skids? What is the advantage? You don't have propeller in the bottom. You don't have propeller, and you can use pretty close to the beach, to the sand. But the sand is the enemy. The sand is the enemy, because if you suction water with sand, you destroy the blades. Yeah, be careful with that. For that reason, the sand and the debris. Yeah, for that reason you need clean periodically with a special cleaner that I explained in my class of intro, the procedure to clean that system. This is the system installed in a jet drive. Yes, my friend, in this system is wonderful. Let me explain why. This is the jet drive, okay? You can install here a gas engine, or you can install a diesel engine, or you can install an electric motor. Depend of your preference. You can use that system, the jet drive, with diesel engine, with gasoline engine, with electric motor. This is a pump of water, the jet drive, and is the efficiency is highly efficient. All right, my friends, in this moment we have three excellent propulsion systems. We have the sterndrive, we have the I.P.S, the iPod, wonderful. We have the jet drive, and we have the surface drive that I explained at the beginning of this video.